Hello, and welcome to the MSc Sustainable Aquaculture degree program. This is a program provided by the School of Biological and Marine Sciences at the University of Plymouth. I am this guy down here in the photo, Dr. Daniel Merrifield. I am the program lead, and I have been for 5 or 6 years, and I am an associate professor of fish health and nutrition. So if you're watching this presentation, you probably already have a good idea of what aquaculture is and why it's important. But on the off chance that you perhaps maybe not so familiar, um, we'll spend maybe just a minute or so talking about aquaculture, what it is and why it's important. So aquaculture is a global industry and it comes in various different forms. So as the name suggests, aquaculture, it really is the cultivation and growing of organisms in an aquatic environment. That may be freshwater, could be marine, or it could be brackish water as well. And when we think of aquaculture, we tend to think of the farming of aquatic organisms to produce food for human consumption, and that is the biggest part of it. But in the wider sense, aquaculture is more than that. Aquaculture is the cultivation of organisms in controlled environments, in hatcheries, that are then used in restocking programs or stock enhancement programs. It also includes the cultivation and rearing of fish as companion animals, so ornamental fish in the pet industry, and more broadly things like public aquaria as well. That's all in a sense a form of aquaculture. And these aquatic organisms, particularly seaweeds, for example, are also cultured not just as a form of food for human consumption, but also as an important provider of raw materials and commodities such as agar and carrageenans, which are used in various different industries, as well as food items as well. So that's an overview of what aquaculture is. I mentioned that it was a global industry, and it really is. It's practiced in over 150 countries around the world. And in 2018, so the most recent data that's available, aquaculture production, global aquaculture production, reached an all-time high of around about 115 million metric tons. And to give you some idea of scale, that's in the same ballpark as poultry production and pork production. So it really is a big food producing industry. So it's already contributing significantly to global food security. But as you know, probably, that currently we already have a food deficit. There are something like 2 billion people on the planet currently suffering from food insecurity, and nearly a billion people suffering from some form of malnourishment. So we don't have enough food currently as it stands, and the global population is growing, and it's growing faster than food production from capture fisheries and from terrestrial farming can grow. So the enhancements and improvements in productivity from capture fisheries and terrestrial farming cannot meet the demand of our growing population. But aquaculture is still a relatively young industry, and it's still growing fast, very fast, compared to those other food production sectors. So aquaculture is growing at a rate of about 5 to 6% per annum. And therefore, it currently contributes around about 50% of fish production worldwide. So the other half or so is coming from capture production. But as aquaculture continues to grow and expand, that will increase to about 60%. So about 60% of fish production annually will come from aquaculture by 2030, and it will continue to grow beyond then as well. So it's a big industry. It covers algae, mollusks, crustaceans, and finfish, and it provides not only good food security, but it also provides economic security. So directly, there are over 20 million people employed by the aquaculture industry worldwide. And if we count indirectly as well, indirect jobs, so jobs associated with, for example, seafood processing or manufacturing of equipment required and used in aquaculture, or we include jobs associated with governance and adherence and policy and research and aquafeed, the producers of diets that are used to feed fish and shrimp. There are many million more as well. So there's a lot of families that are benefiting economically from aquaculture and a lot of jobs. That is going to increase as the aquaculture industry continues to grow. Now, compared to many other forms of food production, particularly terrestrial farming, aquaculture is a highly sustainable way of producing food comparatively. So if we look at the amount of pollution, um, because no food production system is environmentally benign. We have to think about that. We have to accept that fact. There will always be some impact on the environment if we are going to use the environment to produce food. It's not benign. So, but compared to other forms of animal production and terrestrial farming, it's a very sustainable way of doing it. So the volume of pollution per unit, per say kilogram of meat that's produced, is lower than terrestrial farming, or terrestrial farming of say beef and pork and poultry. And the same is true with regards to other mechanisms of output that are relevant to sustainability. So, for example, CO2 or CO2 equivalents, the amount of antibiotics that are used, and so on. These values are all in line with or better than terrestrial animals. So it is already relatively sustainable, but there are always examples of good practice and bad practice, as you would expect with any large industry. So there's lots of examples of good practice and also some examples of bad practice as well. And what we do on the course is we teach students how to understand the difference between good practice and bad practice, highly sustainable activities and low level sustainability. So where we have lots of environmental impact, differentiate between the two. And of course, animal welfare, increasingly important. That's a key ethos within our program, how to farm organisms in a environmentally friendly way, but also with respect for the organisms that you're working with. Okay. The course is taught by dedicated, approachable, and enthusiastic active researchers. So people that are recognized as experts in their field. And their fields and disciplines include fish biology and fisheries, aquaculture, of course aquaculture, but aquatic animal health and nutrition, physiology, behavior, benthic ecology, sustainability of food chains, water quality, aquatic toxicology, marine conservation, food science, ecological economics, and various areas of biology, marine science, and environment. Because our staff are all research active, their research helps to inform and lead their teaching. You can see here on the right-hand side of the screen, classes from previous years. That gives you some idea of the number of students that we like to take on the program each year. So we try to ensure that the class doesn't get too large and too unwieldy, because it makes things a bit more difficult in terms of practical classes and field trips. But also, we think it's important to maintain good staff-student ratios. So we don't like to have the class be too large. And you can see here on the bottom right hand of the screen, we have a number of class socials each year as well. So having a relatively small to medium-sized class is quite beneficial in terms of creating a good course dynamic and a cohesive dynamic within the group. You tend to find sometimes when you have larger groups that you get sort of sub-factions and subgroups within the group. We try to avoid doing that. The program is a one-year program, and that is structured through 3 different semesters. So semester 1 starts within towards the end of September, and it will last until early January. Within that semester, we have 3 modules that are taught in parallel. So the first module is the postgraduate research skills and methods, and this module is part of the accreditation of prior learning scheme. That means that if you go on to undertake a PhD program, either at Plymouth or many other UK-based institutions, you will not have to attend the research skills module there, because this module will be deemed to be sufficient. This module encourages postgraduate students to develop the research and communication skills that they will need in order to carry out research projects effectively. Emphasis is given on the philosophy, design, ethics, and management of research in biology, and effective communication to a range of audiences. The the second module that you will undertake in this semester is called Health and Production in Aquaculture. And this module teaches the principles of the production of aquatic animals and plants and their products in a sustainable manner, with emphasis on scientific advances in health, nutrition, and environmental management. The third module is the Sustainable Use of Resources in Biological Systems module. And this module provides a framework for the analysis of resource utilization and management in biological systems. And on this module, students will examine and evaluate different approaches to more sustainable resource use using both temporal and cultural perspectives. And a range of different evaluation methodologies will be used. The second semester starts towards late January and extends through to April. Within the semester, again, there are 3 modules that are taught in parallel, one of which is the Contemporary Issues in Aquaculture module. This module addresses the key conceptual issues in aquaculture towards the promotion of sustainable solutions to the contemporary problems, whatever they may be, that the issues face at the time. So the content therefore varies slightly from year to year, reflecting the contemporary issues that the industry has to deal with. Key issues in previous years and more recently as well are things like climate change, microbiome, genomics, use of proteomics, feed additives, gut health, emergent diseases, and so on and so forth. Now, this module is taught primarily, or perhaps 50% of the material is delivered by our staff from the faculty, and the remaining 50% of the content is delivered by key stakeholders. So people from the industry, people from policy and governance, people from NGOs, people from government bodies, and so on. They contribute to this program. So that's where we get a really key perspective of what the contemporary issues are and how to deal with them. In addition to that module, you'll also undertake a seafood processing module. And this module appraises different assurance methodologies for the control of and the improvement of quality, safety, and sustainability of seafood production systems. This includes not only seafood products and their transformative and added value processes, but also feed ingredients and aquafeeds as well. The final module that you'll undertake in semester 2 is called Economics of the Marine Environment. And using ecological economics approaches, this module is designed to provide an overview of the economic activities in the marine environment and the associated problems, develop an understanding of how the marine environment and its resources can be valued in both monetary and non-monetary terms, and to develop an understanding of how economic tools and incentives may be used to solve overexploitation and misuse of the marine environment. In the third semester, starting in April, you have finished all of your previous modules and all of your assignments associated with those modules, and you now focus 100% on your research project, and that extends all the way out to August. Now, this module, technically, most students will get stuck into this module when they don't have any classes or any other assignments to do, which is semester 3, but actually it's an all-year module. So some students are very keen and very active, like to get started on their research projects even earlier. So some of them start as early as January, and you're free to do so should you wish to do so. So the research project is based around formulating a research hypothesis and then planning, implementing, and managing that research project to test your hypothesis. The material is taught on the program. This is primarily regarding semesters 1 and 2, so the taught modules, not the actual research module. The material is delivered through a combination of lectures, workshops, seminars, practical classes, field trips, and of course stakeholder lectures as well. And all of the material is brought together within the university's virtual learning environment, something that's called the digital learning environment. And that brings together all of the course material, the the additional material that you need, such as reading lists, the means to submit your assignments, your assignment briefings, um, activities and exercises, directed activities, directed reading, and various other things, all within one roof. So you have easy access to all of the materials and all of the exercises that you will need to undertake from the comfort of your sofa or wherever it is you happen to be all over the world. So a typical week on the program would look like maybe 14 to 16 hours of contact time, either through lectures, workshops, seminars, practical classes, and field trips. Um, and beyond that, of course, we would expect students to be undertaking directed reading as well as undirected reading, completing exercises that have been set for you, and writing up their assignments as well and their assessments. Within the course, we have a number of different field trips, and the destinations of which will vary from year to year, but they tend to include local hatcheries, those for finfish, crustaceans, mollusks, local farms, fish markets, public aquaria, and most of these are day trips, or half-day trips, depending on where they are. You will not need to travel to these locations yourself. The university will provide transport, so a minibus or several minibuses, and we will collect you from campus and take you there for the day or the half day, whatever it may be. In addition to the local field trips typically within the southwest of the UK, we also have a residential field trip. And that residential field trip for the last 5 years has been to Greece. So we go to Greece in late March or early April, and we spend about a week there. And we are hosted by a company called Nereus. Now, Nereus are one of the largest aquaculture companies in the Mediterranean area, and they are a fully integrated company. That means that they have pretty much everything they need in-house. So they have their own brood stock, their own selective breeding programs, their own hatcheries, their own sea pens and sea cages. They have their own processing plants. They have their own feed mills. They have their own marketing teams and the ability to ship products all over Europe and beyond. So it provides a really excellent opportunity for our students to immerse themselves into the industry, meeting some fantastic people that are really passionate about what they do and engaging with those throughout the week as we are hosted at various different facilities. And I'd say for probably most students, this happens to be one of the highlights of the course, because whilst we're there, not only are we learning and enjoying ourselves, but we're also enjoying the nice warm weather, the nice cuisine, the local culture, the history, and so on that you'd expect to find in Greece. So that provides an overview of the course content and some of the important things that you will see and do during the program if you decide to take to enroll on the course. But of course, one of the key things that you will want to know about are the assessments. So how is your work and your learning assessed during your time with us on the course? Well, the one thing to say is that there are no formal exams. So there are no exams throughout the whole of the course. But there are some varieties in different assessment formats across the different modules. And you will be expected to undertake a number of different assessments, which include essays, literature reviews, project proposals, practical reports, environmental valuation critiques, oral presentations, and various forms of open coursework. And we try to build in a high degree of flexibility within not only the modules, but the assessments as well, so that students can focus their efforts on areas that are of particular interest to them. So the aquaculture industry is very diverse, with hundreds, 500, 600, 700 different species that are farmed around the world and taking place globally. So lots of different examples of production systems and different variations of practice in different parts of the world. And it's difficult to try and cover all of that in one program. So we allow students some flexibility within the program for their learning to take them in the directions that are of most interest to them. And that includes in our assessments as well. So our assessments are quite flexible. So for example, one of your assignments where you have to evaluate the sustainability of a system, you get to choose which system you want to evaluate, what species and which part of the world. Or where you have to make economic forecasts or formulate an aquafeed, you can decide the species of interest. When you have to write an essay, for example, on climate change or disease, you can narrow in the focus on the specific area of interest within those topics. The research project module is one of the most important components of the degree program. So it's worth 1/3 of the program. Typically, for most students, will last around 4 to 5 months. Although, as I explained previously, you could start your program earlier, and as early as January, perhaps, and maybe have 6, 7, 8 months to work on your project. Projects each year are diverse. We have a diverse faculty base, as I mentioned previously, so members of staff working in a whole range of different areas, subsectors within the aquaculture industry and peripheral industries as well. And so we have a very diverse range of projects that are available each year, and students can choose from those options, or if something else is of interest to them that wasn't perhaps originally in the list of options available, we work with students to develop bespoke projects as well, as long as they are ethically appropriate and feasible and relevant and practical as well. So practical in the sense of being logistically feasible and financially feasible. The projects could be lab-based, so you could be working with whole organisms in vivo experiments. So you could be working with finfish or mollusks or crustaceans or algae, or if you're not interested in working on whole organisms, you could conduct in vitro experiments. So you could be working on cell culture or tissue culture or subcellular components, or working with single-cell organisms, working with water quality samples, soil samples, various other different opportunities to conduct good laboratory work without having to use whole organisms. A number of field-based studies are available as well each year, so you could be taking environmental samples or samples from farms or hatcheries and bringing those back to the university and analyzing them here. If you're not particularly interested in practical work, you don't have to do any laboratory work. You could undertake a desk-based study. Lots of desk-based studies are available as well. So you could be, for example, working on big data sets or using bioinformatics, or looking at consumer or public perception and carrying out surveys and questionnaires and so on. And each year there are always opportunities to travel internationally, and also opportunities to work with industry. And in recent years, we have had students undertaking their projects and having opportunities to travel to various parts of the world, including Chile, Norway, the Netherlands, France, Oman, Thailand, India, and a whole bunch of other places as well. And of course, across the UK. We have excellent research facilities to support students undertaking their research projects, and also to support the practical classes that we have throughout the program as well. And these include, though are not limited to, our range of different aquaria that we have, and our whole suite of different wet labs that we have that allow students to work with finfish, crustaceans, mollusks, algae. We also have a greenhouse within our schools. So students in the past have been able to conduct aquaponics based projects as well. And as you can imagine, for a large modern university, we also have a whole range of different analytical laboratories that are available to support you as you undertake your research projects. And these include physiology labs, immunology labs, microbiology labs, water quality labs, biochemistry labs, histology labs, molecular biology facilities, and so on and so forth. In addition to these labs, we have some highly specialized facilities and centers that are available at the university, one of which is the Electron Microscopy Center. So we have state-of-the-art scanning and transmission electron microscopes that are available, which some students take advantage of each year. And in addition to that, we have this Systems Biology Center, so access to various different platforms for high throughput sequencing, genomics, proteomics, and various different softwares for bioinformatics as well. We have long-standing relationships with key stakeholders, including those from the aquaculture industry, conservation bodies, NGOs, governance bodies, and various other organizations as well. And these links and partnerships are embedded within the program. So our students have access to expertise and leaders from key stakeholder groups that are pioneering improvements in sustainability. allowing our students to advance both their scientific and technical knowledge, and of course build up a rapport and a network with key people working within the industry in various subsectors and with various peripheral sectors as well. So great opportunities to work with the industry and to build up your future network, which is very important. In addition to helping to deliver material within the curriculum, our industry partners, a number of them, are also generous enough to provide funding, which allows us to provide scholarships for our students. So for a number of years now, we've been providing scholarships worth either £1,000 or €1,000, and a number of these are available each year. Over the last few years, that's been 5 per year. And these funds are for students to spend themselves on supporting themselves throughout their studies. So they don't come to the university. They are not for your research use or anything like that. They are financial benefits that go straight to your bank account that you can use on whatever it is you desire. And these are awarded on a competitive basis each year. So that provides an overview of the course content. And I guess one other thing to think about then is graduate opportunities, or what happens to our graduates. Well, I'm pleased to say that our graduates have gone on to secure employment on every continent of the planet, and that includes Antarctica. And they work in various different industries, various different subsectors, various different peripheral industries, and various different types of positions. Some of them go directly into the aquaculture industry, so working, for example, on farms as farm operators or technicians, or undertaking trainee managerial positions. Others go into areas of research, so for example, contract research organizations, or working in R&D departments for various aquaculture organizations. Some go into areas of policy and governance. Well, many, in fact, actually have gone into working for example, fisheries, aquaculture, and environmental governmental bodies, or are helping to influence policy through working at NGOs, sustainability accreditors, and various other organizations. Quite a few go into secure employment in aquafeed producers, or the producers of raw materials and additives that go into aquafeeds, because aquafeeds are a very large component of the typical operating costs of a farm, taking up to 50 or 60% of a typical farm's operational cost will be from the aquafeed. So it's a really important area of the industry, and it's also key in ensuring good health and welfare of the organisms, but also minimizing environmental impact and minimizing waste. So that's a big area within the industry. Others have gone on to secure PhD programs, so quite a few of them actually have stayed at Plymouth and undertaking PhD programs here. Others are undertaking or have completed PhDs elsewhere in the UK and around the world as well. Not all of our graduates actually stay within the aquaculture industry. Some move into other areas such as fisheries, or become fish health inspectors, or are working in aspects of environmental management, and so on. But wherever our graduates are, we're very pleased to say that they are applying their knowledge and their skills to enhance sustainability and welfare of the aquaculture industry. And we hope that future graduates will continue to do the same. And you will recognize some of these logos here from various important large organizations and companies. And there are literally dozens more that I could show you that have employed our graduates from this program. So if this sounds of interest to you, then you can either contact me directly to get some more information at my email address, which is daniel.merrifield@plymouth.ac.uk, or you can visit our course webpage, which is presented here on the screen.